Hi all, these are the notes for 4.3. This is our last type of solving systems of equations. This is addition. This, for me, is actually like, we all have a way that we go to more automatically. This tends to be mine. But what you'll find is one way will be more comfortable or another. That's fine. So the addition method basically works like this. What you're looking for is to legitimately add the two equations down like you would add a regular, like if I would add 23 plus 14, I would just add in columns, right? I would add 3 and 4 is 7 and 2 and 1 is 3. I want to do that here. And my purpose when I do this addition is to make one of the variables disappear. I'm trying to sort of negate them. So what happens here if I add down is I get -2 and -6 is -8. The y's cancel, plus y minus y, and that's exactly what I want. And then I get x plus x is 2x. And now I just solve for x. So I get x equals -4. And now what I can do is go plug that in to one of the original equations and say -4 plus y equals -2. Add 4 to both sides. And I get y equals 2. So now I know what my answer is. It's -4, 2. And you can check that in the equation. This is the idea of the addition method. The whole idea is to get the two equations together to make one of the variables drop away. So you can see this. You try this one. Do exactly the same thing we just did. Pause, and then turn it back on after you do it. All right, we're going to add down. So 2x plus x is 3x. Y minus y is no y's. 13 plus 2 is 15. And then we're going to divide by 3. So I get x equals 5. That's it. So then I'm going to plug that back in. I get 5 plus y equals 13. Subtract the 5. Y is going to equal 8. So my final answer is 5, 8. All right. So here's the thing. It's not always this simple, right? Of course it's not, because that would just be too nice. Here's how it works. Put both equations in standard form. Here's the thing. If they're not both in the same order first, you're not going to be able to decide what you are going to get rid of. Okay, so we have to have them organized the same way to start. Clear out any fractions or decimals if you want, using the least common denominator or multiply by a 10. Multiply one or more or both of the equation by non-zero constants to create opposite coefficients for one of the variables. You'll see that in a second. Add the equations from step 3 to eliminate one variable. That's what we just did. Solve the remaining variable, substitute, and check. We've done basically everything in here but the first 3 steps, but we'll cover those. So here's a system we want to solve by addition. But what you see here is that, like, I have 3x and 2x, 5y, and -y. Like, nothing's going to subtract away here. It's not going to cancel. So what I'm going to do is I'm going to make it cancel. And the way I'm going to do that is I'm going to multiply one of the equations or both by some number. As long as I multiply all the parts of the equation by the same thing, it doesn't really change its value. It just multiplied it. So I'm actually going to try to multiply this one, all the parts, by 5. And I'll show you why. So I'm going to leave my initial equation alone. 3x plus 5y equals 17. I'm going to multiply the second one by 5. So I'm going to get 10x minus 5y equals -30. And that's exactly what I wanted to see happen. So now the y's are going to cancel. So now I can add. I get 13x, the y's cancel, equals -13, divided by 13. X is -1. Then I want to go back to an original equation. Don't go to one you multiplied, go back to the beginning and substitute. So I'm going to do 3 times -1 plus 5y equals 17, -3. Oh, sorry, I accidentally clicked my mouse pad. Plus 5y equals 17 plus 3. So I get, I should scroll down. 5y equals 20, divided by 5. Y equals 4. So my final answer here is -1, 4. And remember, you can always go back and check in the equation to make sure it works. All right, so you try this one. Think about what you want to multiply by and where. Okay, there's actually, I can think of 2 different ways to do this one right off the top of my head. It doesn't matter which way you use. It matters that you use the way you think is going to work for you. I'm going to show you both. So I have 2 choices. I can decide to eliminate y, or I can decide to eliminate x. We're going to do them each. So if I want to eliminate x, I have to think about, like, how would I get rid of a 4x? Well, I need a -4x. So I'm going to do that. I'm going to multiply the bottom equation by -4. So I'd have 4x on top plus 3y equals 3. And I'd have -4x plus 8y equals a -36. It's fine, works. So I get 8 plus 3, 9, 10, 11, y equals -33 divided by 11, y equals -3. I'm going to substitute that back into the original equation. So I'm going to do -3 minus 2y equals 9 plus 3, -2y equals 12. That means y equals -6. So that's my answer. Does it? Let's see if I did the math right. 2y plus, I think so, right? Okay. So now let's try it the other way. If I had originally wanted to get rid of the y's, what I could have done is multiply the top by 2 and the bottom by 3. Sometimes you're going to have to multiply both. So this over here in blue is the first method, first way. In red, we're going to do the second. So on the top, I'm going to have 8x plus 6y equals 6. On the bottom, I'm going to have 3x minus 6y equals 27. Okay, well, the y's will disappear. I'm going to get 9, 10, 11x equals 33. Okay. Something went wrong in that first one. -3 is right. Sorry, I'm just looking at it because you'll see why in a second. Divide by 11, divide by 11, x is 3. And if x is 3 over here, it should have been, oh, I know what I did. I solved for y twice. That's what I did. I see the problem here. You guys probably already saw it. I know what went wrong. Here's what went wrong. This is why we all do algebra and we check our work. Because I solved for y and then I put it in for x, like a goofball. So I have x minus 2 times -3. That's so much better, equals 9. X plus 6 equals 9, minus 6. X equals 3. See, I knew something wasn't right. So now I'm going to put that 3 back in. And this time I can actually put it in for x. So I get x minus 2y equals 9 plus, minus 3. I get -2y equals 6 divided by -2. Y equals -3. So you can see both ways, same answer. Doesn't matter. Matters that you try one. Try both. See which one is preferable to you. All right, let's try this one. So the first thing you need to notice here is that they're not in the same order. Okay, I don't have A's and B's all in the same place, so I need to reorganize. And I'm going to reorganize this top one. I'm going to move 7a to the other side. And I'm going to rewrite it. I have -7a plus 5b. Oh, that's not a 5. Plus 5b equals 8. And then I have the bottom one, -4a minus 2b equals -10. And then you get to decide what you're going to get rid of. I usually look for where the signs are different. So I'm going to get rid of b's. And the way I'm going to do it is I'm going to multiply by each other. I'm going to multiply the top one by 2 and the bottom one by 5. Okay? You want them to cancel. That's all you really want. So if I multiply the top equation by 2, I get negative 14a plus 10b equals 16. And on the bottom, I get negative 20a minus 10b equals negative 50. Okay, now I'm just going to add them together. So I get negative 34a. B's cancel equals negative 34. So handy when that works out. So a is going to be 1. And then I'm going to go back to an original equation, not to one I messed with, and put in that 1. So negative 4 times 1 minus 2b equals negative 10. Negative 4 minus 2b equals negative 10. I'm going to add the 4. So minus 2b equals negative 6. That means b is going to be 3. Okay, so my answer should be 1, 3. You try the next one, okay? Let's see what the next one looks like. Looks kind of the same. So you reorganize, you solve, okay? Whatever variable you want to make drop away, make drop away. That's up to you. I will tell you when you're finished. You should get negative 4, 3. M should be negative 4. N should be 3. Whenever we make a ordered pair, we always do it in alphabetical order. So it would be M, N. Okay, let's try another one. This one is ugly looking, but it's actually not as bad as you think it is, okay? It's not terrible. Because I know that, you know, I can easily turn 22 into 88. Or I can easily turn 17 into 34. Either way, so I'm going to multiply the first one by, 4 wouldn't do it because then they'll both be negative. So I'm going to multiply by negative 4. So let's see. 34 times negative 4 is negative 136x plus 88y equals negative 16. I left the second one the same, plus 17x minus 88y equals negative 19. I'm just going to combine my like terms. I'm going to get negative 119x equals negative 35 divided by negative 35. It makes a fraction. Holy cow. So x is going to be, well, let's simplify it. It's going to be positive, right? And let's see, I can divide them both by, can I divide 119 by 7? You can check in your calculator. I can. So I can divide them both by 7, so I'm going to get 17 over 7. Okay, I won't die from this. All right, so then I'm going to go put that in for x. It's okay. Put it in the equation. So I'm going to, whoop, I keep clicking on my mouse pad. Oops. All right, so I'm going to replace it. So I'm going to go 17 over 7 times, 17 times 17 over 7 minus 88y equals negative 19. Okay, 17 times 17 is something. I don't know. Let me multiply it. Get my calculator. 289 divided by 7 doesn't actually work. So 289 divided by 7, 88y. You can use common denominators here. That's fine. So I get negative 19. And at this point, like, I'm probably going to multiply everything by 7 just to get rid of that 7 in the denominator here. Fine. So I get 289 minus 616y equals negative 133. Yes, the numbers got big. No, we didn't die. Minus 289. Equals 422. So I get 616y, and then I'm going to divide by 616. And then listen, from here, it's just a matter of simplifying. So I get y equals something crazy, but I know they're both even. I can divide them and keep dividing and keep dividing and keep dividing until I simplify. When you get all the way down to it, it's going to simplify to 3 over 11. Okay? Don't freak out. It's just numbers. They're not here to bite you. They're here to make you money someday. As a grown-up, you like money, right? All right, try another one with some fractions. This one you are going to try yourself. Okay? When you get finished, I will tell you that x is equal to 1/3, y equals 1/4. See if you can work it out. If you get stuck, come into the discussion. That's why we're here. All right, let's try another one. So for this one, since I can, what I'm going to do before I do anything else is clear the fractions out of this bottom one. So I'm going to multiply everything by 4. So let's see what happens when I do that. I get 2x minus 5y equals 4. So I get 2x minus 5y equals 10 on the top, and 2x minus 5y equals 4 on the bottom. Well, so if I multiply the bottom one by a negative, I can switch everybody around. So I get 2x minus 5y equals 10, and negative 2x plus 5y equals negative 4. And those cancel, so I get 0 over here, and I get 6 over here. That's crazy. What does that really mean, though? It means they're parallel lines. Okay, there's no solution here. When you have this sort of instance, we've already seen an inconsistent system before. So when you see this happen, you don't go like, oh my God, I broke it. You go like, oh wait, let me make sure I did the math right and I didn't have an error. And if I'm sure I didn't have an error, it means there's no solution here and the lines are parallel. Okay, you try this one. Again, clear out the fractions, figure out what happens here. Try it. I will tell you once again, these are parallel lines and there is no solution. All right, let's try this one. Well, the first thing I can see is that I need to reorganize a little bit. I need to move the 6x to the other side. So then I'm going to have 3x minus y equals 4 and negative 6x plus 2y equals negative 8. So now I'm going to decide what to get rid of. I'm going to get rid of the x's. So I'm going to multiply the top by 2. And I'll just move it down there and I'll change the color. So if I multiply the top by 2, I get 6x minus 2y equals 8. Oh, interesting. Cancels, cancels, cancels. I get 0 equals 0. What do you know about that? I know it's true. What that means is that these are coinciding lines. They're dependent. This means that all the points are solutions, right? There's infinite solutions. Okay. All right, let's try one more. See if you can try this one. Do what you need to do to work it out. You know you need to move some stuff around. I will tell you when you get to the end of this, it's also got an infinite number of solutions. Just like the last one. Okay, these are coinciding. If you're stuck, come talk in the discussion. All right. So there's just a quick recap here at the end. The methods for solving linear equations in two variables. If one of the equations is written with a variable isolated, it's a good choice to use substitution because it's easier, right? If I have just x, I can pick this up and put it in that spot. Whenever I have a variable isolated, it makes my life easier. That's when I substitute. If both equations are written in standard form, then I can use addition and I can multiply both the top and or the bottom by a value and a sign, a negative if needed, to make one of the variables drop away. If both the equations are in standard form and at least one of the variables has a coefficient of 1 or -1, then either method works. Like you could have reorganized these two equations to make substitution work. Just going to be more complicated. And that's okay if that's the form you want to use most. I know for me, in a situation like this where all the variables have coefficients, right? Addition is sometimes easier, but do what makes sense for you. All right, off to practice. I'll see you in the next one.